Okay, so JEE 2024 Archives on limits. This is a small sample from the first attempt, the February attempt this year. And I would like to advise all of you that if you look across each and every question, you should stop the video there for a minute. Try to solve the question on your own and then look into the solution. Even if you have got the answer, I would recommend you to go through the solution once, because at times my solution may be a bit time effective. That can be the case. So anyways, in every problem I'm going to apply LHR, which is our L'Hopital rule, and you should confirm that for LHR the form is 0 by 0. So if I look across this problem, I know that in the denominator there is a tan square x term, which at x equals to 0 becomes 0. So the numerator has to be 0. And if the numerator is 0, let's just quickly check that. So numerator equals to 0 and 3 plus alpha sine 0, that term is gone. So beta and plus log 1 is again done. So beta comes out to be minus 3, and that is the quickest way of getting beta. Now, as I know the form is 0 by 0, I have got one value, I need other value, I must apply LHR, and I'll get this as alpha cos x, okay, minus beta sin x, and I must apply the log u property, so 1 upon 1 minus x into minus 1, and denominator is then still 6 tan x into sec square x, and it's clear that this term again is going to be 0. That's why the denominator is 0. Numerator once again has to be 0 to follow the 0 by 0 pattern. And then if I substitute x as 0, this cos 0 is 1, so that's alpha. This beta disappears, and this becomes minus 1 upon 1, which is minus 1, which is equal to 0. So alpha is 1. If alpha is 1, 2 alpha just becomes 2. Beta is minus 3, so that's 2 plus 3, which is 5. That's our answer. Now, you can look at the second question. Again, I would advise you to pause the video here. Try to solve the question on your own. And now if you have, I can go through the solution once again. Here, I'm going to use a really nice property. And I know limit x tends to 0. Sin x upon x is 1. And in the back of my mind, this result is 1 only because these two terms are equal in quantity. That's why the result is 1. So, can I say sin x is nearly equal to x? And that is the case. That's why they get cancelled out and the result is 1. अब मैं यहाँ पे effectively sin x को x से replace करने वाला हूँ, and I'm going to rewrite the question once again. उससे मुझे मिलेगा limit x tends to 0 e to the power 2 mod of x minus 2 mod of x minus 1 upon x square. और इसके दो ब्रांचेस बना सकते हैं. एक लेफ्ट हैंड लिमिट LHL रहेगा, एक राइट हैंड लिमिट रहने वाला. बट फर्स्ट लेट्स वर्क आउट LHL. सो दैट्स लिमिट एक्सटेंड्स टू 0 माइनस. और अगर मैं 0 माइनस बोलता हूँ, इट मीन्स दैट x इज लेस देन 0. इफ x इज लेस देन 0, इट मीन्स मॉड ऑफ x इक्वल्स टू माइनस x. उससे चेंजेस ऐसे हो जाएंगे कि ये आएगा e टू द पावर माइनस 2x प्लस 2x माइनस 1 अपॉन एक्स स्क्वायर. ये मॉड ऑफ x अगर माइनस x हो गया तो प्लस x से रिप्लेस हो जाएगा. ओके, सो नाउ आई मस्ट चेक द फॉर्म एंड इट मस्ट बी 0 by 0. So let's check that. If x is 0, then this becomes 0. E to the power 0 is 1. 1 minus 1 is 0. And the denominator is 0. Now 0 by 0 form means I can apply LHR. So this gives me minus 2 e to the power minus 2x plus 2 upon 2x. And again I believe that the form is 0 by 0 because this is minus 2 plus 2, which is 0. Denominator is 0. Again reapply LHR. So this gives me plus 4 e to the power minus 2x. And the derivative of 2 is 0. That's why the denominator 2x's value would be 2. And e to the power 0 is 1. That's why LHL is 2. और वही काम अपने को RHL के लिए भी करना है. तो RHL, I'll write this as limit x tends to 0 plus, and every mod of x will be replaced by plus x now, following the definition that if x is greater than 0, mod of x is just x. इससे चेंजेस ऐसे आ जाएंगे कि ये आएगा e to the power 2x minus 2x minus 1 upon x square. And once again, if I check the form, this is 0, I know that. So 1 minus 1 divided by 0, it is 0 by 0. LHR is applicable. And I'll get this as 2 e to the power 2x minus 2 upon 2x. Again, it's 0 by 0. Again, reapply LHR. So this is just 4 e to the power 2x, constant will disappear, divided by 2. Again, the answer comes out to be 2 as this is 0. Sorry, that's 1. 4 by 2 is 2. And I see that LHL is equal to RHL. So limit does exist and is equal to 2. So that's question number 2. Okay, now moving on and let's talk about this question. So I know that this f is defined from real numbers to positive numbers. It's a strictly increasing function, and it's given that limit x tends to infinity, f of 7x upon f of x equals to 1. Now these kind of questions have this vital information that we can use later on. आगे पूछा गया है what happens to this term. So I can see that there are 3 functional values that I will use. Those are the parts seen in the problem: f of x, f of 5x, and f of 7x. Now, for a strictly increasing function, if I just for a second draw the graph, it may look something like this. This is a strictly increasing function. And then I know that it is a positively valued function because it's defined from 0 to infinity, and it's important to know that all its values are always positive. And since it's an increasing function, this is a statement that I can make, that the value at x for the function would be less than 5x, would be less than the functional's value at 7x. And it is clear from this graph that if this is x, maybe approximately this can be 5x, and approximately this can be something like 7x. So obviously it's clear that 7x's value, this is f of 7x, it's larger than f of 5x, and it's larger than f of x. So now to this expression I can divide throughout by f of x, and since f of x is a positive value, sign of inequality remains same. And now I can apply limit x tends to infinity to all sides. So I'll get this as f of x upon f of x, which is less than limit x tends to infinity, f of 5x upon f of x, and which is less than limit x tends to infinity, f of 7x upon f of x. Now I know that this value is 1, of course, this is given to be 1 in the problem. So I know that our limit lies in 1 to 1, so it's sandwiched between 1, and that's why this value is 1. Now if this value is 1, I just need to substitute this as 1, and 1 minus 1 will give me 0, and that's my final answer. Okay, so this question is a piecewise distribution function question, in which it is given that our f of x answer is going to be x minus 1 if x is even. Okay, so let me just write f of x is actually an odd answer if x is even. Now why do I say that? Because if x is even, x minus 1 is of course odd. एक कम की वैल्यू तो ऑड हो जाएगा इवन नंबर, और अगर x ऑड है तो आंसर 2x है, बट 2 से मल्टीप्लाई करने से तो इवन आंसर आता है. सो इवन आंसर इफ x इज ऑड. नाउ दिस इज अ गुड वे ऑफ लुकिंग एट द क्वेश्चन. इससे काफी आइडियाज अपने को मिलेंगे. सो f of a is actually 21. अब 21 दिया है, इसका मतलब अपना आंसर ये ऑड आंसर है। अगर ये ऑड आंसर है तो x मस्ट हैव बीन इवन, लेकिन फंक्शन ये x के ऊपर ना अप्लाई करते हुए इस हाईलाइटेड पोर्शन पे अप्लाई किया गया है। सो मेरा बोलना है कि f of a must be even and that value must be 22। अब 22 क्यों? क्योंकि अगर इवन वैल्यू होगी तो एक से कम होने वाला है, और 22 को एक से कम करेंगे तो 21 हो जाएगा। सो f of a must be 22। But now again we can use that nesting principle and say that if f of a is 22, it means that now my answer is even, and if my answer is even it means that x is odd, but मेरा फंक्शन x ना होते हुए अभी f of a पे अप्लाई किया गया है, इसलिए मेरा बोलना है कि f of a ये ऑड रहना चाहिए। और अगर ऑड है तो एक्चुअली फंक्शन की वैल्यू ये ट्वाइस हो जाती है। सो 22 किसका डबल है ये मुझे सोचना पड़ेगा। सो 22 डबल है 11 का, इसलिए मेरी f of a की वैल्यू 11 रहनी चाहिए। बट अगर f of a ये 11 हो गया, now I need to think about this because this is really easy now. If f of a is 11, think about this. It means now again it's nesting. F of a is 11 means my answer now is odd. It means that my x must be even. And if x is even, my answer should have been 12, क्योंकि हमेशा इवन को एक वैल्यू से कम करने पे फंक्शन की वैल्यू हो जाती है। सो 12 माइनस 1 11 होने वाला है, इसलिए ए की वैल्यू 11 है। अब नाउ दैट आई हैव आइडेंटिफाइड, सॉरी ए की वैल्यू 12 है, 12 minus 1 is 11, f of a is 11 means a is 12। अगर a 12 है, let me just clear this and write down the solution। So this must be easy now। Limit x tends to 12 minus mod of x cube upon 12 minus box of x upon 12। Now I know that it is 12 minus, so this is slightly less than 12, so this is a fraction between 0 to 1 एंड 0 to 1 का बॉक्स हमेशा 0 रहता है। 12 माइनस यानी मुझे 12 सब्सटीट्यूट करना पड़ेगा, सो दिस इज 12 क्यूब अपॉन 12। माय आंसर कम्स आउट टू बी 12 स्क्वायर व्हिच इज 144 एंड दिस इज आवर फाइनल आंसर अगेन। ओके, सो लेट्स dive into the last problem। All right, so in this case I see that the terms are quite complicated, so I, for confidence, must solve b first. So that's limit x tends to 0 sine square x upon root 2 minus under root of 1 plus cos x. Since the form is 0 by 0, I can apply LHR. I know that it's 0 by 0, so this is 2 sine x into cos x divided by root 2 का डेरिवेटिव 0 हो जाएगा, minus 1 upon 2 root 1 plus cos x into minus sin x. So this is working well for us. This is cancelled, so that's good। ये न्यूमरेटर में चले जाएगा, माइनस साइन भी कैंसिल आउट हो चुकी है, और ये आ जाएगा 2 अंडर रूट ऑफ 1 प्लस कॉस एक्स इंटू कॉस एक्स। सिंस एक्स इज टेंडिंग टू 0, दिस इज गोइंग टू बी 2 into 2, sorry I forgot a 2 here, this 2, so there are 2 2's and under root of 1 plus cos x, so this value comes out to be 4 root 2, and that's the value of b। So I can calculate a now, because that gives you a bit of confidence। a nested value है square root में, इसलिए and it's under root of 1 plus under root of 1 plus x to the power 4 minus root 2 upon x to the power 4. Let me apply LHR here again, because I know that this is root 2 minus root 2 upon 0, 0 by 0 form LHR। So the derivative would be 1 upon 2 root 1 plus under root of 1 plus x to the power 4 into 1 upon 2 root 1 plus x to the power 4 into 4x cube divided by x to the power 4's derivative is again 4x cube। So now we can substitute the value here, and I would get that as, let's check this quickly now. If x is tending to 0, this is 1, this is 1 again, and that comes out to be 1 plus 1, so that's root 2. Let me write that down. 1 upon 2 root 2 into 1 by 2. So that value is 1 upon 4 root 2. And now I need a b cube, so that must come out to be, a is of course 1 upon 4 root 2 into 4 root 2 the whole cube. So this must be 4 root 2 the whole square. This is 16. 4 square is 16. Root 2 square is 2. So my final answer should come out to be 32. And that's it. So I hope you had an idea of how to solve questions of limits from the JEE archives. Okay, thank you so much.